Section 6.6, now we're talking surface area. Now, as you read through the textbook on this, it talks about how we already know how to find arc length, but now if we just take the arc length of a shape and we roll it around the shape, we could get the surface area. So each time you roll around, the shape you're making is actually a circle. So it goes through the whole thing to develop the formula for you, but it turns out the surface area formula is identical to arc length with the exception of two little pieces. You have a 2 pi and you have an f of x, and then you have the arc length piece. Now, this little piece that's right here, this is actually circumference of a circle. Circumference is equal to 2 pi r. F of x is your r. So that's where it's coming from. And the same thing happens if it's rotating the other way and you have to use y's. Again, same exact formula, only we use c and d. And the only thing that's going to change here is that it's going to be g of y is your radius. And so this is 1 plus g prime of y quantity squared dy, just like it has been for arc length. So let's take a look at example 1. It says we have the graph of f of x equals 2 the square root of x on the interval 1 to 3, revolving around the x-axis. So the graph looks like this. And if you revolve it around the x-axis, you're making a parabolic shape. But since we're going from 1 to 3, it's almost kind of like a megaphone. It's going to have a gap at the end. You're only doing this piece right here. That's what's flipping around. Okay, so we start out with my formula. We also need its derivative, which would be 1/2 x to the negative 1/2, and that reduces to just 1 over the square root of x. So, according to my formula, the surface area is going to be the integral. We're using x's, so 1 to 3. We have 2 pi. We have the radius. The radius is the function, so 2 the square root of x, square root of 1 plus the 1 over the square root of x squared dx. Now, cleaning this up, I could pull the 2 pi and the 2 outside because they're numbers. I have a square root of x, and I have a square root of 1 plus 1 over x. Okay, we need to get those two square roots together. So I'm going to put them together. It's going to be x times 1 plus 1 over x, which then, oops, that's supposed to be a 1, turns into the square root of x plus 1 dx. This is excuse me, kind of like a u du, but it's a real simple one because the u is just x plus 1 and the du is just dx. So I can just raise the power on this. It's u to the 1/2. If I raise the power, it's going to be u to the 3/2. And u is my x plus 1. And I flip that in front. And then I'm going to plug in from 1 to 3. So I have 8 pi over 3 times the square root of 4 cubed minus the square root of 2 cubed, which ends up being 8 pi over 3 times 2 cubed is 8 minus 2 the square root of 2. Ooh, I could factor a 2 out of that, which would make it 16 on the outside. And there's my answer. All right, example 2. The reading of this is a little awkward. A spherical cap. It's produced when you take a sphere that has a radius of a and you slice it by a horizontal plane that has a vertical distance of h below the North Pole of the sphere. So that means that h is somewhere between 0 and 2a, because 2a is the diameter of the sphere. And so you get this little dome feature, where this distance right here is h. We want to take the spherical cap and show that the area of the spherical cap of depth h cut from a sphere of radius a is 2 pi ah. Show that the area. Okay. So to generate the spherical surface, we need to take that circle, and that circle is actually has a radius of a, so it's going to be f of x is equal to the square root of a squared minus x squared, because that's, remember, the circle would be x squared plus y squared equals a squared, and you solve it for y, so you get this. And we're going to do it from the interval from negative a to a, because we're going to go all the way across. We're going to flip it around the x-axis. Okay, so the part of the sphere for this h piece, we need to be looking at just the chunk that goes from a minus h up to a, because this distance, the whole distance of the half of the sphere is a, the whole radius, and we only want that little chunk at the top there. So we first need the derivative of f. Remember, a is a number, so the derivative is going to be 1/2 this chunk to the negative 1/2, and then the derivative of the stuff inside. Well, since a is a number, that's gone, but the derivative of the negative x squared is negative 2x. Cleaning that up, I get negative x, a squared minus x squared to the negative 1/2. So let's set up our surface area. We're going to go from a to b, not a to b, a minus h to a. We have a 2 pi. We have the radius, which is the square root of a squared minus x squared. Then we have a square root of 1 minus a minus, so plus, no, 1 plus the derivative squared, and the derivative is negative x a squared minus x squared to the negative 1/2, all squared. Okay, let's try to clean this nonsense up. 2 pi on the outside. We have that square root of a squared minus x squared. Then we have a square root. Oh, this is going to take a few steps. Let's see. We have the 1. We have plus, the square of the negative is going to be gone. We're going to have an x squared, and we're going to have, when you raise a power to a power, you multiply. So negative 1. Okay, now I need all of that nonsense to be in one fraction. So the 1 is going to become an a squared minus x squared over a squared minus x squared. And that's going to cause the x squares to cancel, so you're going to have an a squared on top and an a squared minus x squared on the bottom. Oh, I made that line too long. dx. This is not going through. Okay, so if I want to simplify that, the a squared of a squared minus x squared cancels with the one that's on the bottom, and so then it turns into a minus h to a. All I have left is the square root of a squared, which is a. If you integrate a, which is a constant, you end up getting a x. So I get 2 pi a x from a minus h to a. if I plug and chug my way through that, and the book leaves out quite a few steps on this one, you get plug in A minus plug in A minus H. The A's are going to cancel, the negatives are going to make the H positive, and you end up with 2 pi AH, which is what they asked us to show. That was a tough problem because we didn't have any numbers in it.